Okay, so yesterday we ended off and we had this diagram drawn. Okay, so it looked, I have to recalibrate my smartboard. Okay, so this was 15 degrees. Oh, that's weird. Okay, when that was 15 meters. It's weird to not have that right where you push. Okay, and then we had the 13 meters at 5 degrees west of north. So, all right, so that was those two vectors drawn in there from yesterday, right? And we said our resultant then goes from start to finish like so. All right, so that was where we left off yesterday. So I'd like you guys to kind of finish up the math part of that now. Okay, calculate your x's and y's, right? Find your resultants x and y, calculate the total displacement with the vector on it. Okay, this is going to go off for just a second because I got to recalibrate the board here. It's not writing where I'm pushing. Awesome, I was recording all of that. All right, let's just walk through the next couple of steps here. All right, if I want to find all the x's and all the y's, okay, I've got to set up my trigonometry to find the sides, okay, the x and y components of the 15 and 13 meter vectors. Okay, for the black vector, that's the 15 meter long one. X is the adjacent side, so I'll go cos of 15 times 15. All right, so we're looking at 14.489. And that's meters, and that's east. Okay, and then for our y components, okay, it's going to be the sine of 15 times 15. All right, so it's 3.882. And that's meters north. And then we got to do the same thing with the red vector, the 13 meter long vector. So we're going to have x being the sine of 5 times 13, which is 1.133 meters east. Okay, and then we have the cos of 5 times 13, okay, which is 12.951 meters, and that's north. Okay, so everything, like both the x's and both the y's in this question are in the same direction, which is nice because then we don't have to worry about which ones are negative, which ones are positive. All right, so from there, I should be able to get blue y and blue x. All right, so blue x, you're batting 100, man, or batting 1,000 every time. Yeah. All right. So 14.489 is our x component for the first one, and then 1.13 is the x component for the next one. So we just put those together here. So we got 14 point. Plus our 1.133, 2, 656. Okay, so we're getting our blue x to be 15.622 meters. And that is east. Okay, and our y component, again, we just add those two together. All right, so we'll have our, no, I lost it. Okay, so we'll have sine of 15. Okay, plus Okay, so we're looking at 16.833 for that one. And that's north. Okay, what do I do with those now that I have them? What's my next step? Now I use Pythagorean Theorem, okay, because I have like a squared and b squared. I'm looking for c, right? So I do Pythagorean Theorem with those two numbers, and that will give me the magnitude, anyway, of the displacement. So we'll have our 15.6 squared plus our 16.8 squared, obviously with all the decimals in place. 6219 squared. All right, so we're looking at D is 23. That's not what they have, is it? They messed something up somewhere. I didn't though. I messed something up here. That's exactly what I did. And I said even, oh, this is so nice. They all go the same direction. I even wrote that it was east here. And it's not. And nobody said anything. Guys, you got to catch it when I make a mistake. All right. Now I get to start over again. Okay, so this is not right. Absolutely not right. Okay, let's try that again. But do it right this time. Okay, so we have for our x's. Oh. That's better. 13.355. Yeah, okay, that's better. Meters east. Okay, now we'll get better numbers. Okay, now we're going to use Pythagorean Theorem with these numbers that are right. Okay, so I'm going to shortcut here, guys. I'm going to do this probably the way I shouldn't do it, but I'm going to do it this way just to save some time. Okay, I'm going to round off, but I think in this case it won't make any difference. Okay, so I'm getting 21 meters here, okay, for my displacement, which is what I'm supposed to get. Okay, so 21 meters is the magnitude of D, and then I need to find its angle. Now, I can tell from their answer here, they drew the triangle differently than me because they got an angle of north of east, which means they drew the triangle here. And that's fine. Okay, I'm just going to get the same angle from the east of north perspective rather than the north of east perspective. Okay, so it'll still work out fine. Okay, if we're putting that in, okay, so we'll have second tan of x over y, so 13.356 over 16.833. All right, so 38 degrees, that's the complementary angle to 52. Okay, they add up to 90. So I'm getting 38 degrees east of north. All right, so my final answer here, two significant figures, is going to be 21 meters at 38 degrees east of north. Okay, either one of those answers would be correct on a quiz or a test. Okay, questions on that one? How many people have started number 3 already? Okay, if you haven't, start number 3. Okay, number 3 is going to be a little trickier. Actually, sorry, it's not going to be trickier. It's actually going to be faster. Sorry, I was thinking it was a different one. Okay, number 3 will be a little faster because one of your vectors is due south, which means its x component is 0. It doesn't go horizontally, right? It's due south. It only has a y component, so you don't have to do any trig with a vertical or horizontal line because they don't have one of the components. Okay, because they're vertical or horizontal. All right, give you guys a few minutes on that one. All right, let's just quickly look at what the diagram for number 3 is going to look like. Okay, so we have first, the wildlife biologist goes due south 300 meters. Okay, and then after that, they go 550 meters, 75 degrees north of east. So here's east. Okay, 75 degrees north of east is going to be like this. And I think I didn't give myself enough room. I should have probably made that even taller, but okay, that'll work for now. So this angle here is 75 degrees, okay, and this line is 550, okay, which means our resultant is here. Okay, how did I know that my arrow, my red arrow, should go past where I started? Yeah. Yeah, well, not that, and the angle's really steep, right? So what I have to do is, again, picture scale in my mind and draw my diagram at least partly to scale. That's not really great to scale. Like I said, that red arrow should have probably been even longer than that, okay? But that's all I had room for on the screen. So we have to be careful about making assumptions, because what I often see with this one is people draw, all right, they went 300 meters south and then he went 500. Oh, sweet, it made a right angle triangle and I'm done. No, it didn't. Okay, don't make assumptions like that. The chances that your two lines will add up to a perfect right angle triangle are like astronomical. Okay, so just make sure you're keeping scale as part of what you're doing when you make your diagram. Okay, so let's just have a quick look at some of the trig here. The x component for 300 meters south is 0 meters because it doesn't go east or west, so there's no x component. Okay, and the y component for 300 meters south is 300 meters south, right? So not a lot of math to do with that one. Okay, saves us a little bit of time. And that's like what I would give you on an exam, okay? One that's straight and one that's angled, right? So that it saves you a bit of time. All right, then we have our red vector here, okay? So red x is the adjacent side to the 75-degree angle, so we'll have cos of 75 times 550, and then our y component is the opposite side, so sine of 75 times 550. All right, so cos of 75 times 550. Our x component is 142.350. Okay, and then our y component is going to be 531.259. Okay, meters, that's north. This one is east. Okay, all right, so because we have this kind of simpler one here at the beginning, calculating our resultants x and y is also a bit easier. Okay, our resultants x, or green x, has to be equal to red x, because it's the only time the object went east or west. Okay, so that'll be 142.350. Whoop, sorry, wrong one. The x component. Okay, and then the y component, well, we have to subtract them because we had one that was south and one that was north. Okay, so I'm just going to take that 531.259 and subtract 300 from that. Okay, so we have 231.259 there. All right. Now that we have those, now we can use Pythagorean Theorem to get our overall displacement. Okay, so that'll be square root of, we'll just say y squared plus x squared. Okay. Whoop. Okay, so we got our answer squared plus 142.50 squared. Okay, so our overall displacement is going to be 271.559 meters. And then we have to find the angle. theta. So that'll be 10 to the minus 1. For the way I drew this, it'll be x over y. So we'll have second 10, and we will have 142.352. Oh, sorry, 3504748. Okay, divided by our 231.2592045. All right, so we're getting 31.6 degrees for our angle there. And for our angle, that's going to be east of north. And for this one, we have two significant figures. So they do significant figures differently, or as I like to think of it, wrong. Okay, this number here should only have two significant figures. I used the 75, which is a measured value, to calculate some of my sides. Therefore, this number can only have two significant figures. Okay, so we will be looking at 2.7 times 10 to the 2 meters at 32 degrees, and that will be east of north. Okay, and they got the complementary angle, which is 58, which is fine. All right, questions on how that one worked? Okay, now it didn't take as long, did it? Right, a lot less of the whole finding x and y thing to do. Tanner, question? Right, I use that in trigonometry calculations to calculate sides, therefore it affects my accuracy. Okay, we measure an angle, even if it's measured with a compass, it's still measured. Okay, so how are we feeling about that now? We're feeling a little better. I know the first few times it's really intimidating, okay, and I get that, okay, but it is just always the same. So if you once you get the steps down, it's just a matter of repeating the steps. Okay. All right. And guys, I know like at the beginning of this, it's all kind of, well, it's a review of Science 10, and then I got to learn this skill and that skill. I get that that's kind of boring, okay, but we got to make sure that we get all these skills in place so that we can start applying them to stuff that's a little bit more interesting. And like when we get to projectile motion and stuff, okay, it gets a lot more interesting then. Okay? But we have to learn all the tools first. Okay? All right. Okay, I want you guys to try these. These are super easy. They start out super easy and then they get a little bit more complex as you go. Okay, see if you can try these ones. They start out like collinear, so super easy. Okay, then they become perpendicular, and then you got a few more here that get a little bit more complex. So give those ones a try. Okay, they won't take you very long.